Hello everybody, and welcome to Ask Math Anything. I hope that we're on the air now. It seems like there was a little bit of a delay as we were setting up earlier today, because for some reason when I clicked stream on YouTube it didn't actually go. In any case, I'm glad to be with everybody, and welcome to a session where you get to ask any question, and I get to decide whether or not I want to answer. Well, sort of. I don't really get to decide whether or not I want to answer. I kind of look at the questions and some of them pop out into my eyes as, oh wow, I wonder what the answer is. And somehow I'm just compelled to then try to figure out what the answers are. As you know, if you've been to this live stream before, that means that sometimes I end up trying to solve questions that are too hard. And I apologize to you for that. Instead, what I always try to do then is, as I choose a question, if I can at least get a little bit of an instinct that this might be understandable to students who are learning algebra or geometry, then I'll be more inclined to pick it. All right. Well, yes, I see that somebody said sometimes it ends up being too hard. We do indeed intend for these questions not to be too hard, but it appears that there are a lot of trolls who like to watch my channel and put insanely hard questions into it that look easy. Well, let's see what we've got today. I wonder what questions we have today. Let's go and find out. And Anna Howe says it's always hard. Well, I'll try to be reasonable. How about that? Let's see. What questions do we have? Oh my goodness! Here's a question. What is this? At first I looked at it and I was like, this is clearly a trick question. And then I said, no, it's not a trick question. It looks standard. And then I thought, I wonder if it is a trick question. There's only one way to find out. Let's start to write down this question. So this is by George C.A. I guess George is in either California or Canada. And it says, oh, no, it's from George C. And it says, a man completes a trip in 10 hours. 10-hour trip. Okay, and he travels half of the trip's distance at a rate of 21 kilometers per hour. Half of the distance is at 21 kilometers per hour. Something tells me that George doesn't live in America. You seem to be using kilometers. That's okay. That makes our life easier. And the other half is at the rate of 24 kilometers per hour. Other half at 24 kilometers per hour. And then the question says, how far? What's the total distance? Oh, this kind of question is really easy. The way you do this problem is you just say, look, if half of it is at 21 kilometers per hour and half of it is at 24 kilometers per hour, then you can find the average speed, right? So these kinds of questions are easy. You look at this and you say that the average speed is equal to, what's halfway between 21 and 24? 22 and a half, right? 22 and a half kilometers per hour. And now it's easy because he went for 10 hours, right? So if you went for 10 hours and you if you went for 10 hours at 22.5 kilometers per hour, then obviously the answer is just to multiply the rate and the time. So you multiply these two together and you get the distance is equal to 10 times 22.5 kilometers, which is 225 kilometers, right? No, this is wrong. Don't try this at home. This is wrong. Actually, it's easier to see that if I block it this way. Why? Why is this wrong? So this is actually a trick question, okay? So the question had chosen numbers in a very nice way so that it looks like it's easy just to find the average. But the problem here is that the average speed is not just the average of these two speeds. You see, I can show you an example that shows that this can't be right. Suppose I have a different person. This person is named Bob the Snail. Bob the snail. Why not? Okay, so we have Bob the snail. And Bob the snail is going to go for 10 hours. And Bob the snail goes half the distance is at 0 kilometers per hour. You know what snails do? Snails just like don't do anything. Oh, I have a better one. Not snail. Sloth. That's what I wanted. Sloths. Do you know what sloths do all day? Sloths just sloth around all day. I think they just kind of stay there and sleep or something. So half the distance at 0 kilometers per hour and half the distance at 2 kilometers per hour. Sloths are really slow. So does this mean that the average speed is equal to, what's the average of 0 and 2? 1 kilometers per hour. Is that right? Does that make sense? Actually, there's something really bad about this. Do you know what's really bad about what I wrote down? I wrote down some interesting facts. Half the distance was traveled at 0 kilometers per hour, and half the distance was traveled at 2 kilometers per hour. Wait a second. How could you travel any distance at 0 kilometers per hour? You just can't. You know, if you're traveling at 0 kilometers per hour, you're not traveling. You're just there. And so you don't move. So how could you go half the distance at 0 kilometers per hour? Actually, it's possible. You know what? If you go half the distance at 0 kilometers per hour, can anyone tell me what the distance is? There's an answer to this question. If you have traveled half the distance at 0 kilometers per hour, well, the distance is 0. In which case, this is a really weird question. It's like, well, I didn't go any distance anyway. So I take 0 distance over also 0 time. 0 over 0, what's that? You can't do that. So unfortunately, you can't just take the average of these two. So let's go back to the drawing board. So we can't use the shortcut. Doesn't work. If it doesn't work, then what do I do? Well, if it doesn't work, I need to go and figure out what is the distance. Let's give the distance a number, a letter. We don't know the distance. Let's call the distance x. I don't know what it is. X. Kilometers. Now, if that's x kilometers, let's go and figure out what each of these are. Half the distance is at 21 kilometers per hour. Okay, so let's figure out how much time that takes. That's what we'll do. Let's go and figure out how much time each of these take. So I'm going to erase out the stuff that's bogus. Bogus. So all that's bad. Instead, what I'll do is I'll go and say if x is the distance, then what is, if x is the total distance, then how much time is spent going for this half of the distance? There's a certain amount of time. Can anyone tell me what to do with the numbers? I have x as my total distance, and I want to say that I went half of that distance at 21 kilometers per hour. So how would I figure out what is the time it takes? Well, the time is going to be the distance over the speed. Danny Lamb, what is the question? The question is exactly this. It's the white, the green, and the yellow. So exactly, x over 2 divided by 21, or by 24. So the time it takes for the first part is x over 2 over 21, and that's in hours. Is everyone okay with that? I just took half the distance, which is there, divided by the speed that it took to get the time. And if I do this, if I have it in hours, then this happens to be x over 42 hours. Okay, the next thing that comes over here is the same idea. Let's go and say, what's the amount of time that I took to go here? Well, that would be x over 2 divided by 24. So this has a time which is equal to x over 2 over 24 is x over 48. I just skipped a step. Hours. So can someone tell me a good equation to use? What's a good equation to use? I now know something about how long it took for that first half of the distance. I know how long it took for the second half of the distance. So in that case, I should just go and figure out together it's supposed to be 10, right? So I have an equation. X over 42 plus x over 48 equals 10. Thank you very much. Brian Lee wrote that down too. So now I have an equation. X over 42 plus x over 48 equals 10. So in that case, let's go and solve for x. How to solve for x? Well, I guess I could just try to multiply by some stuff. I have a 42 and I have a 48. That's a 6 times 7 and a 6 times 8. That's good. So let's multiply both sides by 6 times 7 times 8. Wow, that's a big number. So if I multiply both sides by 6 times 7 times 8, multiply by 6, 7, and 8 on both sides, the left-hand side over the 42 is over the 6 times 7, so I just get an 8x. And over the 48 is 6 times 8, so I get 7x is equal to 10 times 6 times 7 times 8. Notice I'm not going to multiply these out until I figure out how to cancel some common factors. Because what I see here is that 8 and 7 is 15. I like 15 because 10 times 6 is 60. 60 is 15 times 4. That's going to be nice. 15x is equal to, let's call it 60, times 7 times 8. Sorry, I'm writing these dots to mean times because I think it looks better than an x when I have an x. It also looks like a period, like a decimal point, but I don't have any decimal points here. So 15 and 60 cancel nicely. Divide by 15, I get 4. Now if only I could multiply. Anyone who has watched this channel before knows that this is the most dangerous part when I attempt to multiply. How do you multiply these numbers? Oh, I have a trick. Okay, it's 4 times 7 times 8, okay? 7 and 8 are consecutive numbers, and 4 is a 2 times a 2. So I'm going to give a 2 to each of them. That is equal to 14 times 16. Now, even I can do this. When I say even I can do this, what I mean is that's not actually going to be done by actually multiplying things out. I'm going to use a trick. There's a trick called a difference of squares. 14 is 15 minus 1. 16 is 15 plus 1. It's really nice to multiply 15 minus 1 by 15 plus 1. Okay, so x is equal to 15 minus 1 times 15 plus 1. The reason this is nice is because if you expand it, you get 15 squared, you get plus a 15 minus a 15, those cancel, and minus 1. So that is equal to 225 minus 1, which is 224. That's 15 squared minus 1. Okay, so we got an answer. The answer is total distance 224. That was kind of close, right? The original answer was 225, which was wrong, but we got 224. But I want to do something else with this question too. So it turns out that this question has another way to solve also. And the other way to solve is that the average speed of doing these two things is actually a different kind of average of the numbers 21 and 24. It turns out that the average speed here is what's called the harmonic mean. That's what Daksh Gupta just wrote. There is a way to do this, but there's a way you can see it too. You know, if I wanted to know the average speed, remember what I was actually doing before. Before I said the answer is 10, which is the hours, times the average speed. So x equals 10 times the average speed. I like this purple equation I've just written. Remember, x is supposed to be 10 times the average speed because the total distance is 10 hours times the average speed in kilometers per hour. So I wonder if I can find a neat formula for the average speed. We're actually going to prove that formula. You see this? If I want x equals 10 times something, I could do that. Let me rewrite this equation. I had x over 42 plus x over 48 is equal to 10. But now I'm going to do something disgusting. I'm going to divide by 1 over 42 plus 1 over 48. Why? Because I could think of this as 1 over 42 plus 1 over 48 times x. So let's now divide by this horrible nonsense. Okay, yeah, it's disgusting. X equals, I'll write it as 10 times 1 divided by, there's a times here, 1 divided by 1 over 42 plus 1 over 48. Oh, that's interesting. So the average speed is going to be 1 over 42 plus 1 over 48. That's what we just got here. right? Because the answer is x. X is the number of kilometers, and that's equal to the time times the average speed. But I can rewrite this in a different way. I can rewrite this in a way where the numbers come. Remember, my numbers, not 0 and 2, my numbers were 21 and 24. Is there anything I could do to this pink fraction so I get the numbers 21 and 24 to show up? If I just took this pink fraction and I did something even more disgusting, then I'd get 21 and 24 to show up. It is equal to 10 times 1 divided by 21 plus 1 divided by 24, all divided by 2. How many people agree that this is disgusting? It's terrible. Why in the world would anyone do this? This looks like you're just asking for pain. Ew. Except that what I just wrote down here is the harmonic mean of the numbers 21 and 24. That's a very special thing. This business, which I just wrote down, is actually not that disgusting. It just looks that way. This is the harmonic mean of 21 and 24. And in general, whenever I go the same distance at one speed, and then the same distance at another speed, the kind of logic we just did shows that the average speed that you went at for the whole thing is this. But how would you think of this? It looks kind of disgusting, but it's actually not. This thing here, in the bottom, is the average of the reciprocals of 21 and 24, right? I take the reciprocal of 21, the reciprocal of 24, and I average them. But that wouldn't be fair, because I shouldn't average the reciprocals. Reciprocals are already upside down. I need to, again, un-upside down them. So I reciprocal them. So the harmonic mean, actually, is the reciprocal of the average of reciprocals. Right? So that's actually quite nice. Yeah, you un-upside down them. And the way you un-upside down them is you upside them. I don't know if that's a word, but you kind of upside them, right? It's like the way you upside down something is you upside down it again. Yes, exactly, right? So that's why you reciprocal the reciprocals. Really what you actually did here, I should be very clear. It's not the reciprocal of the average of the reciprocals. It's the unreciprocal of, well, let me write it more clearly. I didn't leave enough space, but let's do this. It's the unreciprocal of the average of the reciprocals. But do you know how you unreciprocal something? You reciprocal it. It's neat, right? So somehow, this is actually a nice thing about the reciprocals. If you want to undo it, you have two ways. You can either undo it, or you can do it again. And so that's actually what's going on here. And that's actually why you do this step. That's why you reciprocal the reciprocals. It's because you actually need to un it. The key word is you need to un it. There's a reason why the unning is important. It's because of units. You see, because actually all of these have units. This is like kilometers per hour. That's the speed. If somebody told you, hey, I just figured out the speed of my car. My car's speed is 3 million years. That doesn't make sense. You can't measure speed in terms of years. Similarly, you can't go and say, my car's speed is 36 kilometers. That doesn't make sense either. But I guess you could actually say my car's speed is 1 second per kilometer. Wow, that's pretty fast. 1 second per kilometer, what I would mean is that somehow you would imagine that the speed was just saying how long it took, how far you could go in 1 second, right? You could do that. I am Flash. Actually, 1 kilometer per second, that's pretty fast. But in fact, the speed of light is even faster than that. So I guess in the universal scale, 1 kilometer per second is kind of pokey, kind of slow. But in any case, let's go back to over here. Right? So if I wanted to talk about the harmonic mean, the important thing about the harmonic mean is that you're going to average the reciprocals, and then you got to make sure you un it at the end. So that's what's going on here. So in fact, if I saw this problem, exactly how I would solve it is I would recognize that we got the situation here where we're going some distance and we're going the same distance. So I would actually just do this. I would do this calculation, this thing times 10. Is it more efficient? Not clear. It's just that that's how my brain happens to try to solve these problems. All right. Well, hopefully that was a good starting question. I wonder what other questions we have today. Let's see. What? We have another broken calculator problem. These broken calculators seem to have more and more interesting stories around them. So Daniel says, I was doing my math homework while in the bathroom. I accidentally dropped my calculator in the toilet. Don't try this at home. Now 5 plus 4 equals 30. And 8 plus 6 equals 4. Okay. Oh, no, it's not. I read it wrong. 8 plus 6 equals 64. Okay. I also have 5 plus 5 equals 35. And 9 plus 1 equals 27. Now the key question is, what is 9 plus 3? Let's see. What is it? What is it? How are you guys so fast? You guys are so fast. I didn't even get to read the question yet. I mean, I read the question to you guys, but I didn't get to think about the question yet. This is interesting. So I see that what we have here is we have some numbers which, oh, that's neat. All of them have some kind of prime factorization. That's nice. The top number is 5 times 6. This number is 5 times 7. Hey, this number is 9 times 3. Hey, this is 8 times 8. Oh, we can do it, we can do it, we can do it. Right, so a nice thing about this thing is that all of these numbers happen to have prime factorizations. Oh, right, thanks. This is a really cute question. So this 30 is actually 5 times 6. I'm actually amazed by how fast you guys are figuring all this stuff out. This is 8 times 8. This is equal to 5 times 7. And this is equal to 9 times 3. So this better be equal to 9 times 6. Nope, oops, I can't add. This is 9 times 5. Okay, 9 times 5. And 9 times 5 is 45. Let's ask Daniel, is this correct? Was this Daniel? Daniel, are you the one who dropped your calculator into the toilet? Yeah, hopefully it's 45. And please don't try this at home. Okay, more questions. We are being mean to the calculators. This is true. It seems like we always have these random broken calculator questions. But I guess it's kind of neat to see how everyone who comes up with these has like very different kinds of tricks they think of. It just shows how creative people are. You know, some people's tricks involve doing something to each digit. Some people's tricks involve doing multiplication. All right, more questions. Christian Patrick asks, how does a black hole defy physics? I don't know enough physics to answer this question, but my impression was that black holes contributed to the theory of physics because physics has to be able to explain black holes. In some sense, physics is how you describe all of the things that are happening in the universe. So nothing's really supposed to defy physics. Usually if something defies physics, what that means is that you measured it wrong, or physics needs to be changed, right? Because physics is just supposed to be what's actually happening. So it didn't really defy the physics, it's just that people had to go and make a new way to understand how to model a black hole. I don't know enough details about black holes to answer that though. Ethan Gunn. We look like we have some kind of a math problem here, math puzzle. What's this one? So what we have is there are two numbers, I'll call them x and y, whose product added to the sum of their squares. So we have their product added to the sum of their squares is equal to 109. And the difference of their squares is 24. Let's just call it x squared minus y squared is 24. I don't know which one's bigger, but I will just put it this way. When I say which one's bigger, you know, you can have very, very small numbers which square to really big because they're negative. Negative numbers squared could actually be really big, even though the negative number is really small. Oh yeah, the question is, what are x and y? So it's like, got this thing, find x and y. Find x and y. Okay. So I have here an equation, I have like two equations and two unknowns. So what could I do there? one moment. I actually need to restart the recording because the way that our camera system is working, it looks like it just temporarily ran out of footage. 1 second, I'll be back really quickly. All right, I hope that this worked. We'll find out soon. Okay. Everybody do the flop. Huh. Okay, find x and y. Well, I've got two equations and two unknowns, so in theory I should be able to figure out something here. But is there a way that I can do it in a less painful way? That would be nice. As I'm looking at this, I'm like, You know, you can always do these kinds of questions in a fairly painful way, but what could I possibly do here? This is actually, yes, exactly. I also agree, spaced out. I agree, I see an x plus y times an x minus y. That could be useful. You see, I'm trying to say, can I kind of rewrite these equations in terms of something for which I am able to have simpler variables, right? And if I used x plus y and x minus y, I think I got something. Okay, let's try this. I don't know if this will work. We'll try, okay? I got an inspiration. Maybe it'll work, maybe it won't work. So the second one is giving me x plus y times x minus y. That's what this guy gives me. X plus y times x minus y. That's equal to 24. It's not clear that this is going to give me anything better, by the way. Now, when I look at this particular thing, this thing has some relationship between x plus y whole thing squared and x minus y whole thing squared. I might be wrong, but I'm going to try to do something, okay? I'm going to try to do something weird, and let's see if it works. I want to take 3/4 of x plus y whole thing squared and add 1/4 of x minus y whole thing squared. I wonder if anything nice will happen. You might say, this looks ridiculous. Why in the world would you go and take fractions? This had no fractions. But what happens if I do this? If I do this, let's expand this out and see what happens, okay? So if I expand this out, I'll get 3/4 of x plus y whole thing squared. When you square x plus y, what you get is x squared plus 2xy plus y squared. And I might be wrong on the fractions I write in front. We'll find out soon. The second thing I'll do is I'll do plus 1/4 of x squared, oh, it's minus 2xy plus y squared. Okay. Now, I just wrote these two things here because that's just what this is if I multiplied it out. Let's just do it for fun. But what happens if I try to add? The fun part is look at how much x squared I have. I have 3/4 and 1/4. Oh, that's one of them. So this adds up to a full x squared, 1x squared. You know how much y squared I get? I get 3/4 plus 1/4. Oh, I get a normal plus y squared. And how much of the middle do I have? I have 3/4 times 2. That's 3/2. And 3/2 minus 1/2 is 1. Oh, hey, that's kind of cute. So how did I get this, by the way? Do you know how I thought of 3/4 and 1/4? The way I thought of, oh yeah, by the way, why do I care? I care because that is that. And the reason I care about this expression is I'm about to change the variables, and I'm about to say, hey, let's play with a, which is x plus y, and b, which is x minus y. And I'll make a much simpler equation. But first, how did I even know that 3/4 and 1/4 would work? It's because I knew that the x plus y whole thing squared had the x squared, it had the y squared, and it had like more stuff. It had a plus 2xy in the middle. But I also knew that the x minus y whole thing squared, it also has the x squared, also has the y squared, but it comes with a minus of 2xy. And because they both have the x squared and they both have the y squared, I knew that if I averaged the two in some way, then my average of the two would still be x squared plus y squared, just plus something else. If I did a perfect average, meaning half of each, then it would be just plain x squared plus y squared. And I knew that if I did what was called a weighted average, where I put more weight on like the x plus y squared, then I would actually get a little bit extra of xy. Okay, so that's just showing you it's possible to come up with these things. But now once you come up with these things, I have an equation. The equation is that this thing plus this thing equals 109. So now I have a new thing I want to do. I want to say that this guy is called capital A and this guy is called capital B. So I now have an equation. A times B is 24. Over here, I have a squared plus b squared. I also over here get 3/4 a squared plus 1/4 b squared is equal to 109. I claim that these equations, these two equations, are easier to solve. Do you agree? And I know that some people already guessed and checked the answer, but what I want to show is that even if you had a problem with lousy numbers, if you had a problem where the numbers would not let you guess and check, what I've just done gives you a way to turn the original pair of equations into a much simpler pair of equations. And once I solve these equations for a and b, I can then turn it back around and say, let's now figure out what are x and y. Because if I knew the value of a, I could say, okay, then x plus y equals that. And if I knew the value of b, x minus y equals that, and it's fine. So now let's just go and solve these equations. How would you solve these equations? AB equals 24, a squared and b squared. Ah, okay. Maybe this is getting harder than I expected. Let's go do it. So 3/4 a squared. I know, by the way, I know that some people already guessed and checked the answer, but I want to show how you would try to do this in general. Let's start with the yellow equation. Multiply it by 4 on both sides. I'll get 3a squared plus b squared equals 4 times this, which is 436. Three a squared plus b squared is equal to 436. And I also know that AB is equal to 24. Right? Right. Okay. Now if I knew this, how could you try to figure out A and B? Is this possible, or is this also horribly painful? Well, there are a couple of ways to go and do this. I'm trying to think. Yeah, actually, I don't even need to be that clever. I bet I could just do this by brute force substitution at this point. Yeah, we can. Let's just go and do that. Brute force time. There is a clever way you can do it by adding the right thing here and then subtracting the right thing there and getting like two equations to solve together. But we're just going to brute force this at this point. We can do it. Mainly, I want to show you how you can actually solve this even if they were weird numbers. Okay? Brute force. Well, if AB equals 24, what's B? 24 over A. Hooray! Substitution time. Throw it into this. This is not fun, but I'm just showing you how every problem like this can be solved, right? The point is to learn that when you see a question like this, you don't have to say, "Ooh, I have to guess right." No, it's like, just roll up those sleeves. Oh, I guess I don't have to roll up my sleeves. But anyway, like, roll up the sleeves and just like brute force the thing and you'll be done. Okay, let's go. 3a squared. 3a squared plus b squared. What's 24 squared? 24 squared happens to be 576, I think. Help me if I'm wrong, because I might have forgotten this stuff. Over a squared is equal to 436. Ugh! Why did I ever agree to do this? My stomach for brute force is kind of sad. I don't actually really enjoy brute force at all. Now I got lazy. Do I actually have to do this? Well, I said I would. But now it looks like, oh yeah, you're saying, is it a quartic? Well, it's actually not a quartic because it's something in a squared. So the reason I'm not scared is because it's something about a squared. And so I could actually take a squared as a thing, as a variable, and then go and solve this. Yes, the calculator seems like the way to go at this point. Let's multiply by a squared on both sides. I'll get 3 times a squared squared minus 436 times a squared plus 576 equals 0. Is this okay? So, by the way, what I just did is I just took, like, I had a squared, but I'm saying it's actually a squared squared. This is a quadratic equation in a squared. So all I have to do is I just have to go and factorize this nonsense. Do I even want to do that? This thing looks very painful. Yeah, it looks like it might be time to go and call up that calculator. Because if I want to do b squared minus 4ac, 436 squared is not going to be much fun. I hope that somebody here has a calculator that hasn't gone into the toilet. I guess, we could actually go and do this. Or we could go and find out what the answer is. When I say find out what the answer is, I'm looking at this and I'm like, is there a way to factor this? This is 24 times 24. If I wanted to get that big of a number, how could I pull that off? 96 times something? 96 times 6? 96 times 6. Could that be useful? I'm trying to think. Right, because I'm just looking at this. I'm like, whoever asked this question, hopefully you gave me something which had nice answers, or maybe it doesn't. But if I'm trying to factorize this 24 squared is 96 times 6. If I took the 96 times a 3, that wouldn't help me. I'm trying to factorize this in my head, if you can tell. 24 squared. What a weird number. Let's go and find out. Yes, we could go and use this like quadratic formula, but I'm a little bit curious if there's another way. And what you're watching me do right now is attempt to be lazy. So 576 happens to be 24 squared. 24 is 8 times 3. So that's 8 squared times 3 squared. So that happens to be 2 to the power 6. No kidding, really? That doesn't feel right. Yeah, it is. 2 to the 6 times 3 squared. Okay, so now if I've got 2 to the 6, I could do a 128. Could I do that? I'm trying to get a 436 out of here, right? If I'm doing some factorization, I'll be doing a 3 times something, and that something's got to be pretty close to the 436. So I'm looking at whether there are some big numbers here that I can use. 192 times 3, that's too big. So what other things could there be? Well, 436, here's what I'll say. If I want to know what I might need, as I'm factorizing this thing out, I'm like, it's going to be 3 times something plus another tiny thing. And the 3 times something is supposed to give me the 436 almost. So if I want to know what the 3 should multiply by, let's take a 436 divided by 3 and see about what I need. 3 times 1 is 3, minus, so 13. 3 times 4 is 12, 16. 3 times 5-ish is 15. Minus is 1, runs into my head. But so I should wonder, is there any number I could use here which is sort of close to 145, but a little bit less? Okay, 144, by the way, is a number which is really nice. 144 is 12 squared. And this is 24 squared. So 576 happens to be 144 times 12. No, times 4. I wonder if that works. So now I'm wondering, I wonder if I can do a factorization where I do 3a squared minus 4. Oops, let me get more space. Can I do 3a squared minus 4? Whoa, that was weird. Times an a squared minus 144. Would that work? I wonder if that's a factorization. The way I would check is like the 3 times the 144 plus the 4 times the 1. If that happens to be 436, then I'm happy. Oh, and it will be. The reason it will be is because 145 would divide, 3 times 145 is, 3 times 145 and a third is 576. Actually, this does work. Because then 3 times 144 is short of the answer by exactly triple of 1 and 1/3. So I'll say, no matter how you cut it, this is actually going to be the factorization. And one way I knew this would work is because I was like, it's going to be a number close to this. And if you check it, this thing will work. Now I need to say, what's A? It looks like I have a bunch of choices. And in this problem, there may indeed be different answers. But if I have to look at this and I have to go and say, let's quickly go and get some answers so that we can go on to the next question. Like there might be multiple answers, but let's just get one answer to go to the next question. I like a squared minus 144. That's nice, because that suggests that I could try a equals plus 12 or a equals minus 12. Actually, there's a whole bunch of solutions. But of many solutions, of many possible solutions, let's use a equals 12. And by the way, now you also see that when you do the problem this way, This way you could find all the solutions. At the beginning, we saw some people doing a guess and check. And if you do a guess and check, you will maybe find one solution. But how do you know there aren't any more? If you do it this way, what you find out is that no matter what, given what was true at the beginning, this must be true. And since this must be true, that means that A must be 12, or minus 12, or 2 divided by the square root of 3, or minus 2 divided by the square root of 3. That's it. Like, you have to have one of these 4 things. And that's how you can go and show that you have a complete set of solutions. Each of those, you'd go down a path, you'd try to see if it gave you a solution, and if it didn't, you'd call it an extraneous solution. But now we're almost done. If A is 12, what's B? Oh, B is 24 divided by A. 24 divided by 12 is 2. When I said we're almost done, let's roll back. A equals 12, B equals 2. If A equals 12, B equals 2, then I can go back here and I can say A is 12 and B is 2. And these are like standard kinds of questions. I have 2 numbers. They add to 12 and their difference is 2. What are the numbers? Oh yes, the numbers are half of 12 plus or minus half of 2. Whenever I have this kind of equation, I like to solve it this way. I have x plus y equals 12. Oh no, I'm going to rewrite that. X plus y over 2 is 6. That's the first equation. The average of x and y is 6. And this thing here is that the difference between x and y is 2. Now, if I have 2 numbers whose average is 6 and their difference is 2, you can see that from this 6, I should go up and down by half their difference. Does that make sense? This is like a very nice intuition. It's like I have 2 numbers whose average is 6, so they're both averaging here, and they have to be equally spaced around 6, right? Otherwise they wouldn't be averaged. And I need to move until their gap is 2. So I move by 1 on each direction. That's how I know that it's 6 minus 1 and 6 plus 1. So it's 5 and 7. That's how I'd get 2 answers here. So here I would get 5 and 7. But you know what? I did say something about other solutions. Since I've gone all the way here, I should say this is where you can see that there's a value in doing what I just did. I said of all the possible solutions, but there are more. You could also have A equals negative 12. If A was negative 12, what would B be? What would B be? Does anyone know what B would be? You have to do 24 divided by negative 12. So B would be negative 2. Now if B is negative 2, let's go back. Oh wow. If we go back, if B is negative 2 and A is negative 12, what happens? Negative 12 and negative 2. Oh wait, by the way, when I said 5 and 7, I need to be careful. Not 5 and 7, 7 and 5, because x was the bigger one. Okay, now I have an average of minus 6. And if I have an average of minus 6, then I have to say that I will move, well, x minus y is negative 2, so the gap has to be again 2, but in the other direction. So now it's minus, I think it's minus 7 and minus 5? Yeah, minus 7 and minus 5. I have another solution. Does this actually work? If I plugged in x equals minus 7 and y equals minus 5, yes, it works. The reason it works is because if you think about what happened with this being x equals 7 and y equals 5, if I minus both of them at the exact same time, then the squareds, they don't change. And the x times y both get minused, so it also stays the same. So what we just found out is, this is where guess and check is dangerous. Guess and check would not have told you that there's other solutions. But we just found another one. And now you got me curious. Even though I said we'd go to the next question, I got curious. Are there weird solutions? Okay, back to this. Weird solution time. The next one I want to do is where I say a squared is equal to 4/3. If a squared equals 4/3, I have 2 divided by root 3. That's weird. I know I could rationalize the denominator. Let's worry about that later. If a is 2 divided by root 3, I could rationalize later. We'll worry about that later. What is b? b is 24 divided by that. Okay, that looks like it might be 12 root 3. Now I have some weird numbers, okay? Now I have that a is 2 over root 3, b is 12 root 3. What? Let's go back to the problem. Maybe that's possible too. What was a? A was the sum, b was x minus y. So let's go and get a clean screen and just write down that x plus y is the a, x minus y is the b. So x plus y is going to be this thing, 2 over root 3. Over root 3. And x minus y was equal to 12 root 3. Now, how do you solve these? The same thing I've been doing before. I go and say, take the average, right? So from the first one, I get the average of x and y. And I know you can solve these in other ways. I just somehow always think of it this way in my head. X and y over 2 is 1 over root 3. So that's like the average of them. And now I need to go up and down so that the difference is 12 root 3. So I need to go by 6 root 3. Half of that, okay? So when I do that, if I combine with the second piece, what I get is x is equal to 1 over root 3 plus 6 root 3. And y is equal to 1 over root 3 minus 6 root 3. Whoa! Does this actually work? I mean, by the way, you could simplify this. You could simplify this by saying this is root 3 over 3. Okay, I should actually erase this part. Some people, actually, not just some people, whenever you write this up as a solution and you submit it, say, in math counts, they don't think this is simplest form because it's not. 1 over root 3 is like root 3 over 3. And then plus a 6 root 3. What that is that's equal to 19 over 3 times the square root of 3. I hope, because I just took the 6 is 18 thirds, all right? And then over here it's with a minus. This is root 3 over 3 minus 6 root 3 is equal to, oh, this is hard. What is this? Minus 17, maybe, over 3 root 3. Here's where I need help. Is that actually true? Minus 18 plus 1. I hope it's right. I hope. Someone tell me if it's wrong, okay? So I now have these two pieces. This is x and this is y. Does it actually work? What was the equation that I have to check? The equation I have to check is xy plus x squared plus y squared. Whoa. What is it? xy plus x squared plus y squared. All right. Multiply time. Multiply these two. X times y. Ooh, the square root 3's cancel. That makes me a little bit happy. So I get negative 19 times 17 over 3 times root 3 squared, which is 3, okay, plus x squared. X squared is 19 squared over 9 times 3, plus y squared, which is 17 squared over 9 times 3. Ah, disgusting. But what's the answer? If I want to put this all together, that cancels. Okay. That thing puts a 3 down. I'm just curious if this actually works. That's going to be a 3 down there. All right. Now what do I do? Oh, why not 9? Did I make a mistake? It could very well be that I made a mistake because I always make mistakes on these things. Let's keep going. So what do I have now? I have some horrible thing. So I have equal to divided by 3 of 17 squared plus 19 squared minus 17 times 19. Is that right? We'll find out. Wrong. Bottom is 9, not 3. Okay, there might be a mistake. And people are saying there's a mistake. Oh, x times y. Yes, that's right. Because I was like, it doesn't look right to be canceling away. Good. Because it seemed like it broke symmetry somehow. This one should be 9. Yes. When I said it broke symmetry somehow, what I mean is that it's weird that in some cases I got 3, and the other case I canceled it all away. So that would leave a 3. Okay. So what this leaves you is, yeah, actually that is what I wanted. So this over 3, and this is going to be 17 squared. Funny thing is the thing I wrote down next was actually correct with this mistake. 17 times 19. Gee, I wonder what this is. How would I figure out what this is? I have a trick in mind. Do I have a trick in mind? I'm not sure if I have a trick in mind. Maybe I don't. I think I do. No, I don't. No. Okay, so this is not actually very nice. All right, what is this? Some horrible number. What's it supposed to be? It's supposed to be 109. Is it actually 109? Let's find out. Okay, now I have to actually go and do some multiplying. Oh, I'll tell you how I'll do this one. The way I'll do this one is I will say, if I really had to do this because I'm lazy, I'll call this 19 minus 17 whole thing squared. Okay, this is 19 minus 17 whole thing squared plus 17 times 19, all divided by 3. You're watching how I attempt to do arithmetic. The way I try to do arithmetic is I try to do as little as possible because I'm very liable to make those mistakes. What I've just done here is I said 19 minus 17 whole thing squared. Well, that would just be this plus this minus 2 of those. That's nice. 19 minus 17 whole thing squared, I can do. That's 4. So this is equal to 4 plus, but you know how I like to multiply 17 and 19? The way you multiply 17 and 19 is as 18 minus 1 times 18 plus 1. And 18 squared, is it 324? Someone help me out. Is 18 squared 324, or did I forget? I guess I would have to think again. 18 squared, 26. 324, it is, yeah. So it's 324 minus 1, 323. All over 3. This is 327 over 3. That's 109. So actually, it works. Look at that. X squared plus X squared plus Y, no, XY plus X squared plus Y squared, it is 109. With these crazy numbers. Well, I have one more thing to check. X squared minus Y squared. Hopefully that's easier. Oh, I know that X squared minus Y squared is going to work. The reason I know that X squared minus Y squared is going to work is look where we got these X and Y. We got these X and Y specifically so that they would add to 2 over root 3. And you can see that they do. If you add them, it's 2 over root 3. And they subtract 12 root 3. So in fact, X squared minus Y squared is just that times that, which is 24. Boom. X squared minus Y squared happens to be X plus Y times X minus Y, which however you do it, including just plugging in that stuff over there, is 2 over root 3 times 12 root 3, which is 24. So what we've just found out is that there is a crazy answer. This. That's the wrong way to draw a box. This. Now, it's not very likely that you would have used guess and check to guess that. How do you point? That. It's very unlikely you'd use guess and check to point that. It's crazy. Who would guess that? But that's the value of doing what I had just done here. You might have said, like, why did we waste all our time doing this in such an inefficient way with like all these weird X squareds, Y squareds, there was an A squared, there was a B squared. Why did we do all this when you could just guess the answer? The answer was obviously just 7 and 5. Well, it's because there were actually 3 more answers. The other answer was minus 7 and minus 5. The other answer after that was weird and weirder. And the other answer after that is negative weird, negative weirder. You just like negative both of them and it would actually work. So that's this question. Thanks very much for asking this. I hope that it was somewhat interesting to you. I also hope it was somewhat understandable. You've basically just seen some ideas here, which, Ethan Gang said, whoa, I gave this problem and I didn't even know this. Well, you know what? Neither did I. When you gave this problem, I was like, gee, I guess we could try to guess and check, But is there a general way we can solve this where we solve it? Like we brute force it, but we also know that there are no other answers. And it's very powerful. We know that there are no more answers precisely because we got it down to this line. When we did all this, like algebra, and you got to this line saying, no matter what, your A has to satisfy this, it's that statement that says, then you have not much choice for your A. It locks your A down, and you only have 4 choices to check, the pluses and the minuses of each square root. Okay, well, we got a few minutes left. Let's talk about some maybe lighter question. Oh my gosh, Michael Wu asked, how do you derive the formula for an ellipse? Were you motivated by this question? Oh gosh, I don't quite remember, but it seems to me that these kinds of shapes are often related to ellipses or squares, but in this particular case, this one doesn't look very elliptical to me. I'm just looking at this again. I'm a bit rusty on doing these calculations fast in my head. I'm trying to imagine what does the graph of x squared plus y squared plus xy equals 109 look like. And it actually should be elliptical. Why I said it should be elliptical is because this equation is the same as this plus this equals 109. And what that means is that actually if you go and change the axes, you kind of turn 45 degrees, it actually shows that, okay, this is now Algebra 2, far too complicated for today's live stream. But I have a gut feeling that if you go and plot this thing, you'll find some kind of an ellipse where the ellipse is like tilted 45 degrees. And how do you derive the equation of this? That would be the subject of another much more complicated live stream. Yep, Desmos. Yes, actually, if somebody has Desmos, I suggest you type this in, and I'm pretty sure what you're going to end up seeing is an ellipse that's tilted 45 degrees. Okay, more questions. I see. Okay, so let's just finish with this one. This like nice thing to mention. So, let's see. Yeah, let's go and do this thing here. It's like there's a question by Carrie Lu. How can you get into a good college? I think everyone might be wondering about what to do with college right now. Actually, even after they got into college, because what's going to happen with COVID and college? Hopefully we can solve that. But how do you get into a good college? I'm just going to give you this answer. Just, do your best, learn. I'm glad that you're here on this live stream. If you like the kind of crazy journey that we're going through to go and learn all kinds of different topics, use that in your own way of learning. Whenever you're trying to learn about something, just be curious. Learn some stuff around it. Is this going to get you into a good college? Well, actually, it's probably going to get you pretty far. And we can't have everyone in the world all go to college X, whatever college X is. So don't go and say I'm good or bad whether you get into college X. What's important is just like go ahead and learn. Don't just do things so you can pick up an achievement. And if you go and learn, you'll get into a good enough college, and after that, you'll go and do some pretty good things. And that's what matters. All right. Well, that finishes our live streams for this week. Hope you guys had fun. We will have a very different kind of live stream than the daily live streams tomorrow because it's a Saturday. And so what happens is on Saturdays at 8 o'clock p.m. Eastern Time in the United States, we have a live stream where, I'll talk about some problem which maybe I came across. And then after that, we take random questions about anything except these kinds of math problems. These math problems, please save them for the daily live streams on the weekdays. With that, I wish you all a very happy Friday or Saturday already, if the case may be where you are. See you.